Hello, class. Happy to see you. Um, Hope you are doing okay during this period. Hang in there, be self-disciplined, self-directed. Okay, hope you'll be all right. Now, I'm going to share with you the answers to our worksheet 10.2, which I did not complete the other time. I'm sorry I can't see you on Zoom live because of logistic problems, but no worries. Okay, I record some videos, and if I can, I will meet you on Zoom at some point. Okay, so I'm going to just go through the answers for worksheet 10.2. That day we were talking about um, the differences between boiling and evaporation. All right, if you remember, boiling uh, occurs at a constant temperature, while evaporation occurs at any temperature, right? Now, you must remember that boiling and evaporation occurs for many substances and not just water. So in your exam answers, please don't write boiling occurs at 100 degrees Celsius because it can also occur for any other substance, all right? So it need not be at 100 degrees Celsius, okay? But water is just one example, right? So for water, boiling occurs at 100 degrees Celsius, while evaporation occurs at any temperature, okay? So when you answer, you must write generally. So you say that boiling occurs at a constant temperature. Then the second difference, okay, boiling occurs throughout the liquid, while evaporation only takes place at the surface. Okay, um, evaporation because it takes place only at the surface. So if you increase the surface area, evaporation will occur faster, right? Okay. Then number three, bubbles are formed in the liquid during boiling, while evaporation, there are no bubbles formed. And number four, heat is supplied by an energy source during boiling, while heat is supplied from the surroundings during evaporation. So if you have a puddle of water on the floor, right, after a while it will just evaporate by itself without an obvious heat source because energy is obtained from the surroundings. So evaporation does not have to have a heat source, all right, an energy source. Okay, so number two, what is the similarity between boiling and evaporation? Boiling, okay, and evaporation, there are many differences, but there are similarities as well. Both of them involve a change in state from liquid to gaseous state, okay, and both require heat energy. All right, both require heat energy. Okay, so those two are the similarities between boiling and evaporation. Now, if at any point during the video you cannot catch up, you can just pause the video and copy down the answers. All right. Now we come to number three. Okay, we have not discussed this. This is a question about evaporation. All right. Now you see there's ether in the flask here, right? And there's a very thin layer of water between this flask and the wooden support. Okay, it could be a tabletop. Now this thin layer, this thin layer of water, all right, something will happen to it when you blow air into the ether, all right? So what happens is when you blow air into the ether will evaporate quickly, okay? It's just like alcohol, right? Because it has a low boiling point, so during normal temperatures, room temperatures, it evaporates rather quickly. So if you add air, okay, you supply moving air, right, it will evaporate even faster. So when air is pumped into the ether evaporates rapidly, okay, and the temperature of the ether drops to below 0 degrees Celsius, right? And it cools down so much that it drops to below 0 degrees Celsius. This causes the water below the ether to cool and freeze, okay, to become ice. So in other words, the ether became so cold that even the water layer below freezes, okay, because heat is removed from the water, from the surroundings, okay, which includes the water layer below, such that, okay, it freezes. All right. Okay, so evaporation has a cooling effect because when evaporation happens, the more energetic molecules will leave the liquid and leaving behind only the less energetic molecules, right? So that means the average energy of the molecules left behind have decreased. Okay, that means you only have the slower moving molecules left behind. And because the temperature is proportional, okay, the temperature, let me write this down. Okay, I'll write it down. So because the more energetic molecules have left the liquid, right? Okay. So when the more energetic molecules leave the liquid, what is left behind will be the less energetic molecules, right? So when the less energetic molecules are left behind, so if the less energetic molecules are left behind, the liquid becomes cooler. That means there's a lower temperature. Okay, so this liquid will now be at a lower temperature. Okay, right? So the temperature drops. Right? Okay, so that's the cooling effect of evaporation. So let's go on to 3B. Okay, so hence explain how perspiring helps to keep bodies cool. Okay, I think there's a spelling error here. Helps to keep our bodies cool. Perspiring cools our bodies, okay, because of the evaporation, okay, of our perspiration or sweat. And heat is required for evaporation, okay, so heat is taken away from our bodies, right? So heat is taken from our bodies, and therefore, okay, since our bodies supply the heat for evaporation to take place, our bodies will experience a cooling effect. All right, so that's what happens. Now, some animals, they cool themselves in different ways, right? But the concept is similar, the method is similar. For example, dogs, right? You can see that they will pant, right, with their tongues sticking out. That is also to help enable evaporation to take place. And that helps the bodies to cool down, right? So evaporation of our perspiration helps to cool down our bodies because heat is taken away from our bodies when evaporation happens. Okay, I'm going to go on to number 3. Okay, why does washing dry faster on a warm, windy day? Now, there are two keywords here, warm and windy. So there are separate points, okay, that we need to address. Warm, okay, evaporation occurs faster when the temperature is higher, right? So this, you can see this at work when you're using a hair dryer. right? If you want your hair to dry faster, you turn the mode of your hair dryer to hot air, and it will help evaporation to take place faster and your hair dries faster, right? So secondly, besides warm, okay, how about windy? Movement of air also helps evaporation to take place faster, right? So when you have a bowl of soup, when you blow, all right, on your soup, okay, it does help to cool it down because it increases the rate of evaporation, right? Likewise, if you have perspiration on your body and there's a big gust of wind, you can feel that you can feel cold, right? Because evaporation happens faster and heat is taken away from your body, right? Okay, let's look at part B. When the washing is spread out rather than leaving it in a pile, what happens? Okay, when you want to dry your clothes, you always want to spread out your clothes, right? Our HDB flats, we will put it on a bamboo and then we put it out to dry, right? So when we put it out to dry, we always spread it out. We don't leave it in a lump, okay, right? Or all in one lump. We will definitely want to spread it out. So when we spread it out, we are doing what? We are increasing the surface area of the liquid, right? So when we increase the surface area, the rate of evaporation also increases. So likewise, if you want your bowl of soup to cool down faster, you use a saucer, right, which has a larger surface area, and it will cool faster as well. Okay, so I've come to the end of this worksheet. All right. I would like you to continue with the SLS lesson on heat transfer, okay, where you will be learning about conduction, convection, and radiation. So I just want to encourage you to stay the course, be hardworking, be diligent, okay, be self-directed, and enjoy your learning. I will be seeing you soon.